The second law is the law of areas. It says a line joining the planet and the sun sweeps out equal areas in equal time intervals. This is a line joining the planet and the sun. When the planet is here, this line sweeps out this big an area in, say, 3 days. When the planet gets there, the line also sweeps out the same area in 3 days. This means that when the planet is farther away from the sun, it travels a shorter distance in 3 days. When it is closer, it travels a longer distance in 3 days. This means the orbit speed must be slower when the planet is farther away, faster when it is closer. It would be the slowest when it is here at the apogee, farthest away from the sun. It would be the fastest at the perigee, closest to the sun. As the planet travels from apogee to the perigee, it would speed up. When it goes from perigee to the apogee, it would be slower and slower and slower. If the orbit happens to be a circle, the orbit speed would be a constant. Now let's prove this. Equal area in equal time intervals means the area is being swept out at the same rate. Area divided by time is a constant. The area is the area of this triangle. If we look at a very short amount of time, then this is kind of straight. That means the area is the area of this triangle. What is the area of a triangle? It is 1/2 height times the base. To find the height of the triangle, I have to extend this line and then make a perpendicular line right here. This is the height of this triangle. When the planet is here, its velocity is along this line, which is a tangent to the path. So this is the line of motion of the planet. And that distance here is the perpendicular distance between the line of motion and the axis. So the height of this triangle is the perpendicular distance, the perpendicular r. As for the base of this triangle, that is the base of the triangle. The base of the triangle happens to be the distance traveled by the planet in time t. If we say the time is a very short amount of time, that means we can say during that time the planet pretty much travels at a constant speed. Therefore, the distance traveled in time t would be v times t. So the base of the triangle is v times t. The t's cancel. This being a constant means 1/2 perpendicular r times v is a constant. Since 1/2 is a constant, that means perpendicular r times v is a constant. Since the mass of the planet is not going to change, if I multiply this by the mass of the planet, I should also get a constant, which means m times v times r perpendicular is a constant. And what is this? That is the angular momentum of a point mass. So this is the conservation of angular momentum. They are equivalent to each other. Since the angular momentum is conserved when the net torque on the object is 0, this is true for any central force. Central force means the line of force goes through the center. The gravitational force is the only force acting on the planet, and the gravitational force does go through the center. So the gravitational force is a central force, and the central force has 0 lever arm, therefore 0 torque, so we have the conservation of angular momentum.